Hi guys, I'm Ankita. In this video we shall see another problem on LeetCode. Minimum flips to make A or B equal to C. So given three positive integers A, B, C, you have to return the minimum number of flips that are required in some bits of A and B to make it equal to C. And A and B we do the OR operation. What do you mean by OR operation? If either of them or both of them are 1, then the result will be 1. If both of them are 0, then the result will be 0. That is the case. So it means 0 0 will give you 0, then 0 1 will give you 1, 1 0 will give you 1, 1 1 will be 1. If any one of them or both of them, a single 1 is found in the bit, then your resultant will be 1. So in this case it's 0, yeah, because both of them are 0. This is our operation. So flip the operation consists of change any single bit 1 to 0 or 0 to 1. That is a binary representation. So let's say the example A equal to 2, 6, B equal to 6 and C equal to 5 is given. So I hope you know how do we represent a given number in a binary format. So as you write, it's a base 2 format. To 2 power 0, 1, 2, 3. 2 power 0 means 1, 2, 4, 8. So if A equal to 2, how do you represent? So except 2, all the bits will be 0. Then for B equal to 6, 4 plus 2 will be 6. So those two bits will be 1, the other bits will be 0. Again for C equal to 5, 4 plus 1 is 5, so those two bits will be 1, the other bits will be 0. This is how we represent a given number in a binary format. Now, we should do the XOR operation, OR operation of the A or B. So if you do that, as you know, 0 0 1 0, 0 1 1 0, as we have here, it's given over here also. Now, 0 or 0 will be 0, okay, 1 or 1 will be 1, 0 or 1 will be 1, 0 or 0 will be 0. But is this equal to C? If it is equal to C, then no flipping is required. If this is not equal to C, then there is requirement of some bits to be flipped. So we'll not store the resultant. Instead, what we will do is, if you see the logic actually, uh, just now imagine that we are taking single bit in the sense least significant bit. Most significant bit will be from the left side, least significant bit will be from the right side. So now imagine we are taking the least significant bit, okay? We are considering the first least significant bit, which is that this. So 0 or 0. What is 0 or 0? That will give you 0. But is it equal to the least significant bit in the resultant C? If it is equal to 1, is it? No. So if this is not equal to 1, what can be done? We can flip either of the bits. Either in the least significant bit in A can be made to 1. It can be 0 0 1 1. Or you can make 0 1 1 1. Least significant bit in B equal to 1. Do we need to do both of them to 1? Yes, you can. But what they have told here they have said like we have to find the minimum flips to make A or B equal to C. So we consider that either of them we are making the flipping the bit to 1, not both of them. Both of them can be done, but here it is not necessary. Here we have to find the optimal number of flips. I mean, actually optimal means minimum number of flips that has to be made to flip the bit to 1. So in this case, if let's say, how do we get the least significant by the way? We get the least significant bit by like 0, 0, 1, 0. If you do AND with 1, we'll get to know whether the least significant bit is 1 or 0. This is nothing but 0, 0, 1, 0 and with 1. So remaining bits will be 0. So if you do AND operation, it's like if both the bits are 1, then only the answer will be 1. So 0 or 1 will be 0 and remaining will be 0 because here you could see all the bits are 0. So this means we are getting the answer as 0. So let this be x. Okay. Then y be equal to, we do the b and operation with 1. So what if you do b and with 1? So if you do and with 1, 0 and 1 will be 0 only. Again you getting answer as 0. Then store answer c and with 1. How much it will get you? C and with 1 will get you 1. That is the least significant bit. So let this be stored in C. So this is for A, this is for B and this is for C. Okay. Why we doing this? We are having one more integer to store the least significant bit of all the three values. So now you have to check whether x or y, if it is not equal to z. X or y means least significant bit in A or B, if it is not equal to z. If it is equal to z, do we need to do flipping? No, that is not necessary, right? If I take this bits, let's say 0 or with 1, that will give you 1, which is equal to 1 here. So you need not to flip any bit. So in that case, you need not have any count. So let's have a variable called flips, okay? Initialize to 0. So now if you check 0 or with 0, will give you 0, which is not equal to 1. So in this case, what have we done? In this case, first you have to check if x or y is not equal to z, the one what should be done? First you have to check if c means in the z least significant bit is equal to 1. Then flips plus plus. When will you get x or y is not equal to z, though z is 1? If both of them are 0. If both of them are 0 only, then you will get it not equal to 1, right? If either of them is 1, then 1 or with 0 will give you 1, or 0 or with 1 will give you 1. So this won't there. Only if 0 or with 0 will give you 0 and not 1. So it's not 1. So in this case, you have to flip either of the bits to make the z as 1, least significant bit as 1. Got it? Okay, once this is done, now we have to move to the next bit. This bit, second bit. So how do we move? For that, we have to right shift the both A, B, C by one position. So if you right shift means you're dividing the given number by 1. So 2 by 2 will give you 1, 6 by 2 will give you 3, 5 by 2 will be 2.5, which is approximately 2. You can check if you do right shift of A by one position, this will move, right? That will give you 0, 0, 0, 1, which is of course 1. Again, if you do right shift by one position of this, then this will give you 0, 1, 1 and 1, 0 over here. So that is nothing but 2 per 0, 2 per 1, 3. Yes, correct. If you right shift this by one position also, this will be 0, 1, 0, 0, 1, 0, extra 1, 0. Can add it. So this is nothing but 2. Got it? So right shifting means dividing by 2. If you do left shift, you are multiplying it by 2. So when you do right shift by one position, that is nothing but, so A equal to A right shift by one position, B equal to B right shift by one position, C equal to C right shift by one position. So once you do this, again you find the least significant bit. So once you do right shift, you have 1, 3, 2. So, okay, yeah. So you have 1, 3 and 2. How is 1 represented? That is this bit only. Now we are looking at. So I'll point over here. Okay. 1 and with 1, what it will give you? 1 means 0, 0, 0, 0, 1. 3 means 0, 0, 1, 1. 2 means 0, 0, 1, 0. So if you do and with 1, and with 1, and with 1, so 1 and 1 will give you 1, then 1 and 1 will give you 1, 0 and 1 will give you, oh sorry, I have made a mistake, okay, 0 and 1 will give you 0. This means the least significant bit in 1 and 3 are 1, but in 2 it is 0. You have to check whether that is equal to, now what you have to do, you do the XOR operation of what? 1, sorry not XOR, or operation, 1 or 1 will give you 1, if it is equal to Z. Is it equal? 1 is it equal to 0? No. So what it means? 1 is not equal to 0. So that means in this case Z is not equal to 0, 1. It is 0 actually. So how do we get it? So else condition we have to check. Else, first we have to check if both x is equal to 1 and y is also equal to 1, then what should we do? We need z as 0, but we have both x and y equal to 1 in this case. So that means we have to flip both the bits. Then only the OR operation will become 0, right? So flip plus equals to 2. Because we have to flip least significant bit of b and a also. Why? We need z equal to 0. And it's not matching with the answer. Because both least significant bit of a and b are equal to 1. What if one of them are 1? So let's say 0, 1 we have. 0 or 1 will, or with 1 will give you 1, which is not equal to 0. So in this case, only one of them is 1. So that comes the else part over here. Flips plus plus. Okay. First we have to check if z is equal to 1. So this won't match if both of them are 0. So one of them you have to flipping. So flip plus plus you do. Otherwise, if z is equal to 0, then you have to check if both of them are 1. If both of them are 1, then both have to be flipped. And if one of them are 1, then 1 has to be flipped to get z equal to 0. So these are the conditions. Again you do right shift by 1 position. So 1 right shift by 1 position 0 0 0 0. Then b right shift by 1 position means will give you, this will be right shift 0 0 0 1. This right shift by 1 position will give you 0 0 0 1. Fine. So should we need to continue the loop still? Yes, we have to, until all of them become 0, we have to continue the loop. Again you do the XOR operation, same thing will be done. Same procedure will proceed. So we should quickly code this now. Let's have a variable called flips equal to 0. So while a greater than 0 or b greater than 0 or c greater than 0, what has to be done? So int x equal to a and with 1, int y equal to b and with 1. Similarly, we'll have a variable called z equal to c and with 1. Next, check if z equal to 1. Okay, not before that, you have to check if x or with y. If it is not equal to z, if it is equal to z, nothing has to be done. No flipping is required. Let it be as it is. If it is not equal to z, then you have to check if z equal to 1, then both has to be flipped, right? Because if both of them are 0 only, it is not equal to z. So one of them we can flip to get it as 1. Else, you have to check if first you have to check if x equal to y 1 and y also equal to 1. Then flips plus equal to 2. Else flips plus plus. At last we should return number of flips. And yeah, before the loop ends, what you have to do, a equal to a right shift by 1 position. Similarly you do for b and also you do for c. Yes. Okay, this should be y. Yeah. And for Java also same logic, nothing, no syntax change also you have in this. So we shall submit this. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.